Have you ever seen a controller that looked fine on the outside, but the rain sensor wouldn't shut off the water, or you had an error message on the screen? When the controls aren't working or programmed properly, even a perfectly designed irrigation system can fail. That's why reviewing the system controls is one of the most important parts of an irrigation inspection. In this section, we're going to look at the brains of the irrigation system, the components that decide when, how long, and how often water is applied. These controls impact efficiency, plant health, and whether a landscape is in compliance with Florida watering laws. I'm Dr. DeBusk, and in this lesson you'll learn how to observe and evaluate controllers, rain sensors, pump start relays, soil moisture sensors, and weather-based ET devices as part of a professional system review. By the end, you'll know what to look for, what to test, and how to document what you find. When we talk about system controls, we're talking about the components that decide when water is applied, how often, and for how long. These include the irrigation controller, a rain sensor, a pump start relay if one is present, and any soil moisture or ET-based weather sensors. You've already learned about how each of these devices works in the videos Control Systems in Irrigation and Sensors and Control Accessories. So now we're shifting to the inspection side, what to look for during a service call. The checklist you see here outlines the preventative maintenance tasks for these control components. Now, every service company will have their own process and their own paperwork, but this example shows one clear way to document observations during a system review. When reviewing an irrigation controller in the field, the first step is inspecting the physical condition of the cabinet, wiring, and internal components. The controller is the master switch for every zone, so any physical problem here will affect the entire system. I start with the exterior. Is the cabinet mounted securely? Is the casing damaged? If it's installed outdoors, is it actually an outdoor rated controller? I also want to see that power wires and valve wires are protected in conduit and not left exposed to weather or weed trimmers. Next, I open the cabinet and inspect the interior. I check for a blank display, error messages, or alert LEDs. Icons like no AC, system off, or rain sensor active can reveal immediate issues. I also check for pests inside the controller. Ants, roaches, lizards, and even snakes show up more often than you think. Finally, I look for burn marks, corrosion, loose wires, missing station wires, or a bad battery. If needed, a full service call may also include measuring voltage in ohms, especially during spring startup. The goal here is simple. Verify that the controller is clean, powered, protected, and physically capable of operating the system correctly before we ever examine the programming. Once the controller passes the physical inspection, I review the programming. First, I confirm the current day and time. Mechanical clocks will always drift a bit, but they should still be close. Then I check the watering days. In Florida, that means no more than 2 days a week in summer and 1 day in winter, unless it's a drip zone, which is exempt. This is where systems often fall out of legal compliance. Next, I confirm the controller is set to auto or run. Some homeowners turn it off between waterings, especially retirees who only run their system manually, so I make note of that if it applies. Then I review start times and run times. Irrigation should run between 9 p.m. and 9 a.m., and there should not be a separate start time for every station. Each active zone must have a watering day, a single start time, and a run time programmed. Otherwise, that zone will never water. Finally, I check that the rain sensor is not bypassed. If it's set to bypass or off, the controller will run even after rainfall, which defeats the purpose of having a sensor and waste water. Measuring voltage in ohms is a standard part of spring startup or yearly maintenance on a controller. These readings give us a baseline for each station, so when a problem shows up later, like a weak solenoid, damaged wire, or failing relay, we can spot the change before the system fails. It's really about prevention, not reaction. By measuring and recording these numbers on the irrigation service checklist, we create a reference that helps diagnose future issues quickly and accurately. To measure voltage, set the multimeter to 200 AC volts and turn on station 1. Put the black probe on the common terminal and the red probe on the station terminal, then record the reading. Move the red probe through each station and the pump master valve terminal. Only the active station and the PMV should show voltage. Then repeat the process by turning on each station one at a time. For ohms, turn all stations off and switch the meter to 200 ohms. Again, black probe on the common, red on each wired station terminal, and read the readings. There's no reason to test empty terminals. Once everything is recorded on the checklist, you now have a complete electrical snapshot of the controller. Rain sensors, also called rain switches or interrupt devices, are required on all irrigation systems in Florida. They prevent unnecessary watering after rainfall, but only if they're installed correctly and kept in good condition. During the physical inspection, I make sure the sensor is mounted where rain can actually hit it, not under a roof line or a tree canopy. I check that the disc stack cap is intact, the spindle isn't broken, and the vents aren't clogged with moss, debris, or bird nesting material. For wired sensors, I look over the cable for cracks or exposed wiring. At the controller, I confirm the wires are attached securely to the sensor terminals or on older systems tied into the common. If it's a wireless unit, I check that the receiver wiring is clean and secure. One last detail. If a sensor is wired in, the jumper must be removed or the controller will ignore the sensor completely. After the physical check, I verify that the rain sensor is actually communicating with the controller. First, I confirm the bypass is not set to off or bypass. If the sensor is bypassed, the controller will water even after rainfall, which defeats the purpose of having the device. For wireless sensors, I inspect the receiver and look for communication lights or display icons. They should show that the sensor is connected and active. Some models will also show battery levels, bypass indicators, or signal strength. If I see any alerts or warnings, I document them on the service checklist before testing. A rain sensor must be tested at least once a year to make sure it actually shuts the system off. To test it, turn on a zone you can clearly see from the sensor's location. For Hunter controllers, make sure a manual all stations or manual program start cycle is initiated, not a manual single station cycle, which bypasses the sensor. After you set your controller, press and hold the manual test spindle. When I do that, the sprinkler should shut off. When I release it, the sprinkler should come back on. If it's a wireless unit, you can still run the same physical test. Indicator lights alone are not enough. It's important not to soak the disc stack to test functionality. Wetting it can keep the system shut down for 48 to 72 hours, which may cause plants to miss their next watering. After the test, I make sure the sensor is back in active mode before leaving the site. A pump start relay allows the controller to turn the pump on and off automatically, so the inspection here is quick but important. I make sure the relay cabinet is secure, not cracked, and that the wiring is protected, ideally a conduit leading back to the controller. I also check the conduit and connections where the relay ties into the pump and controller. Finally, I verify that the two 24-volt wires are firmly attached to the common and the P/MV terminals inside the controller. Just a few simple checks can prevent nuisance pump failures and service callbacks. Soil moisture sensors are becoming more common on both residential and commercial systems, and they're inspected much like a rain sensor interface. The buried probe itself is not part of an irrigation system review. That's handled by a trained technician, so our focus is on the interface at the controller. I start by confirming the interface is mounted securely and that all wiring is tight. Since these devices piggyback on a valve wire, there should be a clean connection from the field into the interface and then from the interface back to the controller's valve terminal, with 24-volt power tied in as well. Finally, I check the display for alarms, error messages, or override settings that could prevent the sensor from doing its job. Weather sensors, or ET sensors, measure climate conditions to adjust watering based on how much water plants actually use. They only work with smart controllers, and they all communicate wirelessly. The inspection is very similar to a rain sensor, but placement is even more important because the sensor needs exposure to both sun and rain for accurate readings. Make sure the sensor is mounted in the open, not under an eave or tree, and that it isn't damaged or covered in pollen, algae, or debris. Check the wiring at the interface and inspect the antenna, whether it's internal or external. Finally, verify communication by checking the LEDs or the controller display for icons, warnings, or low battery indicators. If the sensor can't communicate, the controller can't self-adjust. Here is an example of a completed controller section of the irrigation service checklist. In this case, there were no error messages and the display was good, so it was marked OK. Ants were found living inside the controller cabinet, so that issue was marked 1 and then checked off once it was corrected. The exterior condition and battery were both in good shape, so those were also marked OK. Because the controller had power and operated normally, there was no need to check the GFCI or breaker, and that section was marked 0. The programming and rain sensor were functioning properly, and because there was no pump start relay on this system, that line was marked NA. For companies that include voltage and resistance testing as part of preventative maintenance, those findings are shown in the second example. None of the stations that were not turned on showed voltage when another station was active, which is exactly what we want to see. The output voltages and resistance readings for each active station were recorded, and the unused terminal, station 6 in this case, was simply marked NA. The exact checklist format will vary by company, but the purpose is consistent. Document what was inspected, what was discovered, and what was done. This gives the customer clarity and provides a useful reference for any future service call. Before we leave a site, the goal is to make sure every control component is physically sound, communicating properly, and programmed to run efficiently and legally. That means inspecting the hardware, verifying the settings, and testing devices like rain sensors so we know they're actually working. When required, we also benchmark voltage and resistance readings so future problems are easier to diagnose. Finally, everything we observe gets documented. A clear checklist not only protects the customer, but also helps the next technician, prevents repeat visits, and keeps the irrigation system running the way it was designed.